Hello, welcome back to our CSCI 310 cybersecurity. Just letting you know, I already post kind of like the last project. So will be there's a two parts for the project, and you need to do. Firstly, I just like give you a scenario. So you need to I give you some tips. So you need to figure out how to describe the message. Okay, if I give you the um describe it. So I will telling you there's something called the AES advanced encryption standards, like with the passphrase, and then there's a base 16 for encoding, and then the CSCI for unknown shift. Okay, so just like giving you some hints. Okay, so you need to identify how to decode the encryption layer, and then based on this, like how can you doing the reversing each layers to get your plain text. Okay, so like what's the message, what you're sending, or and then maybe time or event refer to this one, and who sent this one. Okay, and you need to one more thing is like, because you already know how to decrypt it, then because you need to verify, so you need to do the re-encryption to validate. Okay, so how can you do that? So I try to give you some encryption method, so you need to study and then figure out it. Okay, so try to give me some time and show me the step, and if you can make the screenshot, you can do it. Okay, so try your best to answer the question. So mostly I try to show your effort. Okay, how to solve it. And second part will be just like some case study. So need to just pick any real case. So because if you know some network security incidents, so you can choose any one of it. So just like give me some summary, and then what kind of like encryption, what kind of method they try to okay, being broken, or the how do they bypass? Okay, or like why they being like implement poorly? Okay, so what they like how actually like have a technical breakdown, and then what's the impact, or some what did you learn from this issue? And there's some suggestion, but you don't really have to like pick one of these, just anything. Okay, I try to give you enough time. So suppose once you post it, so I know you may be working on your the assignment, also last assignment, and because I give you kind of like a month to complete, so hopefully you have developed time. Okay, so it already available on D2L, so you can try to check it. Suppose you have a 1 month to prepare this one, so you should be okay to submit it. Okay, so also because I cannot extend it anymore, because it will be kind of the last project. So this your last project before the submission of final grade. So just like letting you know, because we have the final exam will be pretty similar to our midterm. So it will be like complete online. So most of them they just say a multiple choice. Okay, just remember to choose the question, like it takes like almost like over 50%, 60%. Okay. But to me, I thinking it's like meaningless. Like if you below 60, okay, just like getting a fail. Okay. So that's why giving a question. So remember to answer it. And just like come back to our class, because we have a last chapter, so it's going to cover in our later like three class. Okay, so on Thursday, the next Tuesday and Thursday, so there will be the last chapter. And for today will be just like recap. Okay, so about a previous lecture. In our previous lecture, we talked about checksum. So we know like checksum, so we're going it's a small size value, so it like derived from a large data set. So we have a specific algorithm. Okay, so we use it to detect the errors in data transmission or storage. Okay, and as a first step, we always try to ensure the data integrity, and also we want to detect the errors in the data, like maybe during the transmission or storage. So you see always when you try to open files, so we look at the checksum. For the file verification, so maybe we can use the SHA 256 for download file, or sometimes we can use for like network protocols, like including the TCP/IP checksum for the error checking. So all these we can apply it. So mainly we try to break the data into a fixed size block. Okay, and then we can apply a mathematical algorithm to generate a checksum. So this one is sent or stored with the data. Okay, so after we receive, we calculate the checksum, then they will compare with to the one. Okay, so do you think, okay, because if we're sending a checksum, so it's possible that, okay, the checksum is wrong, okay, the value is wrong, okay, so but they match, so they are possible. So it caused some crash. Okay, so these are different. How can we improve it? For this way, it's pretty one of the good methods. So help us to doing the two use case, like file verification and network protocol. Like, and if I tell you, okay, if we have the hello string, right? So the checksum, we're going to sum all the ASCII value. Okay, the ASCII value of all the characters, and then they will model a number. So we can pick, let's say if we use then 256. Okay, if we actually 256, then we can add all of them together. So right here, if you have an exercise, if you doing so, if you want to learn, if you convert all this value to ASCII code, so you should like maybe have some idea what's the ASCII code. So then because they are capital number, and then add them together, and then module 256. Okay, add them to a module, so you will get the checksum. So once you send this value, or we send it this a string with our calculate, okay, checksum value. So we can we compute one more time and compare. Okay, so in case, let's say there's a maybe the R changed to another letter, so that checksum value will be changed. Okay, not the same. So then we know, okay, so it's not the original message. And right here, when we talk about the ASCII, okay, so you need to like recognize they are referred to character encode standards, and those like character, they have a corresponding numeric value. Okay, let's say if we say C is 67 and Y is 89. Okay, of course you can find it online. So there's a lot of like ASCII table. So okay, so there's a lot you can find easily online anywhere. So not only the letters like A, B, C, D, but also even others characters. So but for ours, we focus on this time will be the ASCII code for our all capital letter. So we will start from 65 to Z. Okay, upper Z will be 90. Of course, like if your message string contain maybe like lowercase special character numbers, then all the numbers will have more. Okay, so depends on the question if you see, you have to calculate. Okay, and when we calculate, we are just like adding all these values. So like cybersecurity, we have all the value right here. So here, the first step, so we try to match. So once you match to the table, then you will get all these value right. And the next step, we're just like adding all the ASCII value together. So sum the value. And because we saying, okay, we have a module of 256. Then what's the meaning of 256? If you remember, like when we doing the maybe the asymmetric, okay, using the public key. Okay, so we have the if you remember the equation, C equals to what, and then D equals to what. Okay, so also we have concepts called the modular operation. So this one is like returning a remainder. Okay, so which are divided by a specific number. So in this case, we're using the 256. Okay, so 256 is not of course it depends on the encryption mechanism or the checksum, but this time we say, okay, if we're using 256, then you have to for it. So the result of the like calculated value, so will be within a certain range. If we're using 256, then it should be 0 to 255. So for a checksum, okay, and this number is like really quick. So once you modulate it and you get the quotient, okay, and we can get the remainder. So if sometimes for this one, for the division, okay, so if we model 256, then the remainder will 108. So you can do it in this way. So pretty straightforward, like just pretty simple math. Okay, so you can calculate. Then we have something that you need to know why we're using specific like 256, just like let you think about, okay, so if we can confine any like specific range, then we can easily like, especially using some like byte order operation, then we can easily calculate. And if I tell you, okay, so if I giving a cybersecurity 1, 2, 3 like this, so what's the value of this one? So if you're in class, then I will give you time to do it. But if you're watching, if you want to calculate, then you can try to answer this question. So try to get it. Okay, so if you model it 256 again, so what's the final value? Okay, but you need to matching this one. I adding the numbers, numeric number. So you need to find what's the ASCII values. Okay. And there's some more. So if I 106, if I change the one of the string like the character, let's say I change C to D. So what's the value? Okay, once you change, so you can like observe it. Okay, and there's a one question ask you. Okay, so there's any potential weakness, like as I say, like for the checksum. So this one you think about thinking maybe for checksum, it may be pretty useful, but we may be fail, okay, to detect some more like sophisticated type of data manipulation. Let's say this is intentional tampering or cryptographic attack. So you maybe get the same checksum, but the content, the string already altered, okay, being modified. Okay, so you are not able to get it. So just be careful. Checksum is not always like, very powerful. It does have its own like, weakness. Okay. And then right here, when you move on, if you remember, we have the digital certificate, right? So we have the digital certificate. So just like we recap of it, we have it's an electronic documents. So we use it to provide ownership of public key. Okay, so it contains the information about the key, identity of its owner, digital signature of an entity. So they have like verified certificate or contents. Okay, and those like digital certificate. So they are crucial components of the public key infrastructure. So this is called a PKI. So it's like when you see a term PKI, it's a public key infrastructure. So they are really widely used for communication of the internet. So nowadays we mainly use lots of different types of certificate if you look at it. And if you remember last time I showed you the wireless campus, so if we go to right here, and if you want to check, so you have if you look at the connection, okay, if you search it, so you say, okay, we have the connection is secure and the certificate is rated. And when you look at this part, so you see who issue it, okay, issue to the CN, okay, command name, organization, or sometimes the unit, okay, issued by, okay, and organization. So if you remember, I talked about we let's encrypt, and then when they issue it, so I think they pretty renew it just like recently, and this one only lasts for like from March to June. So like, and then they'll renew later, and then they will have the fingerprint. So for the SH256, the certificate, and then they do have a public key exists. Okay, and of course we have more details. So something like E6 right here, and under E6 we certificate will come with the version, serial number, certificate signature, algorithm, and so when you click on this, you can get all this information. Okay, where the T is right here, like not before. Okay, and then not after, like this range the time, and then PKI. Okay, so what's the public key algorithm we are using? Okay, and also we have more like extensions like right here. You can find all these certificate. Okay, and right here, you can see like I quickly go through like when using the Venice campus, and then if you come back, so once we come back, then you can have more detail right now. Okay, so just the thinking is more like your passport, right? So you know the ownership of the public key. So like who own this one, and of course from a third party. So from the Venice campus, this one is created by Let's Encrypt. Okay. And for public key, so this one can be the share publicly, so and use it to encrypt the message. So if you refer back to the Redis canvas, then you know, okay, where's the public key? Okay, because for public key, we don't really care about it because like Build is open to public because we let you to encrypt it, and also because we have the third party like to trustable third party to issue it, and then we have the called the issuer, the certification authority. So CA will verify your identity. Of course, we have different type of third party. Some of third party, if you want to get their digital certificate, you have to pay for them. Okay, they you need to submit some supporting documents, know who you are. Okay, but for some, just like for free, then just like called a self-sign certificate. So and you see the validity period. So this one will be which is a valid and serial number. So it will be the unique identifier for the certificate, and also we have the digital signature. So the signature of the CA, the certification authority. So we certify this offset and other information. Okay, given right here, and you can find all this information. The certificate information right here. Okay, so it's pretty easy. Okay, and nothing really changed. You can see maybe for the issuer. Okay, the in this field. So it's the Internet Security Research Group, and then the US. Okay, like this. Signature algorithm. Okay, serial number. If we talk about the version. Okay, and validity. So right here, you can match all this content. Okay, so right here. And if you remember, we in our lecture we talk about like 509. Okay, typical like what's the 509? So right now is the most common format using. So we need to specific the version. So most common we using like v3. So try to find. So you can find the version. Okay, so what's the version right here would be v3, and then we have the serial number, you say signature algorithm. So most of we're using is the SJ256. So sometimes come with the RSA2. So using asymmetric, they combine them together and issue. Okay, so different will be the who issue it. And will be like that. And of course, we have more like we're busy like not before and not after date, or we have the subject. So subject will be the certificate. So the issue, okay, is for several individual. Okay, also maybe the subject public key info. So it will tell me what's the algorithm like associated with this, RSA or ECDSA. So there are different type of it. So if you're following, not only checking the Web Campus or any website, you can find and then actually look at their certificate. Okay, so then you can see, okay, right here you see there's RJ256 with the RSA encryption, okay, or the key algorithm right here. So we have another one, okay, DCPK, okay, so public key or subject right here, okay. And we have different types. So if you look at those different websites, maybe they're using different CA. Okay, certificate authority to sign their certificate. Okay, so that's what you see different types. Or sometimes they have their unique identifier for the issuer, or sometimes for subject. Okay, they're kind of optional. They're not really required. And also there's extensions. If you see the extension, so they'll provide some external information like key usage certificates that policy. So refer to right here, this part, like extensions. Okay, so extension key right here, and then maybe like basic constraints. So it's a certificate authority, a maximum number of intermediates a 0. Okay, or subject key ID. Okay, maybe the certification authority key ID. Okay, right here, authority information access and certificate policy. Okay, not critical. So you can find all these information, okay, to check this. Usually we are so easy access. So not only just like look at the slides, but also nowadays it's so easy to access it, and then you can find it. So try to look into those certificates and compare the differences. Okay, and so far just like we care about in the lecture is giving you more detailed information. For the workflow, when we need to use those certificates, so we need to have an entirety. Okay, in the beginning, maybe a website or individual. So they need to generate public private key pair. So we say the asymmetric, okay, key. And then we need to request a certificate from a CA. And then CA, we try to verify the identity of the entity, okay, who is like requesting the certificate. Okay, because like later we're saying we need to know who you are. And that can involve a validation an organization identity, and also maybe they will try to verify the domain ownership, checking other document. Okay, of course, when doing if you are using less than encrypt, if you know like building a website, okay, so that one is much more simple. That one is showing, okay, this one is your website, you own this domain, and that's it. Okay, it's much more simple. Okay. And then the certificate insurance. So once the CA verify the entity's identity, it will issue the digital certificate. So they will contain the public key. So we know the public key. And so identifying information, they will sign the certificate with their own private key. So if you remember in our lecture, we try to use it in both. So this one will also sign it with their private key. So there's a process like doing the public key exchange. So when the entity, okay, their website and or sender, so they want to share the certificate with others, then the certificate will contain the public key. So this key can now used like by anyone for to securely they communicate with the entity. So it's like doing. But when for tampering or like for store identity, man in the middle. That's why we need the certificate showing, okay, this public key is sending from the entity who is the sender. Okay, so by who giving you. So we have authority to certify you. Okay, this from you, this key is from this entity. Okay, so here's the idea we need to do. And then for the verification by recipient, so if somebody received this certificate, so they can use the CA public key. Okay, so this one always say maybe available or some pre-installed trusted store. Okay, so we can verify the authority of this certificate. Okay, make sure this signature match to the CA. Okay, so if they match, that means that this certificate is available. Okay, that means that we need to check the certificate first. Okay, but like in case somebody like try to making a fake certificate, okay, give me another key. Okay, so we need to validate their signature about the certificate. Okay, so once we can validate, so we know this certificate is valid, then we can use this public key to encrypt the message. So like this. So let's say if there's a website and then we need to establish the secure communication. So like if first try to generate the public and private key pairs. So it's a step one. So for the private key, just remember we try to keep secure on the web server because they for yourself, right? And then public key, you're going to have digital certificate we're sending out. And when we do the certificate signing request, CSR, then the website will try to create the CSR with the public key. So along with the information about the website, so including the subject name, domain, etc., any information. So this CSR, so they send it to the CA. Okay, so maybe like that called the less encrypt digit share or any other authority that can give you the certificate. So they will once they receive it, they will try to verify. Okay, verify the details of the website and show the organization or individual actually own the domain. For less encrypt, it's like even lower security. Okay, so they just verify. Okay, you have your domain, and then you already configure. So just like server domain ID. Okay, they match. Then they will give you. They will issue the certificate to you. So once they authorize verify it, the that means they issue a certificate. So it including your public key, domain, and then some information of your website. Also the CA digital signature. Okay, they will like certify that the information is accurate. Okay, so after the next step, then you need to install the certificate. So install it. If you want to know the more like practical, I will show you. Okay, and like the website actually there's a digital ocean you can share. So it's pretty straightforward and easy. And once the user access it, you visit this website, then of course they will check the certificate. They verify first the certificate is signed by the trusted CA, and then next it will check the validity period. So ensure this like certificate they are not yet expired. And then later, if I verify everything, then you can use the public key in the certificate to establish the encrypted connection using SSL, TLS, SSL, all this. Okay. And there's some type of digital certificate. You can just have some idea. One is called the domain validate certificate. Okay, so they just verify the ownership as well as say the let's say encrypt, we can do it. So you just own this domain. So cheapest, fastest to issue, or some are just free if you're using less encrypt. So suitable for personal website or blog. Okay, but for the organizational weighted certificate, so it need to verify first your domain ownership. That means that you own this domain, and then your identity of your organization. So this one will give you high level trust than the DV, the domain weighted certificate. Okay, so if for some like business or especially the organization, then it's better to use the OV certificate. Okay, and this one more called extended validation certificate, EV. So you will perform more extensive verification. So not only the identity, but also like, do they have a legal, physical, operational existence? So they will like checking, okay, where's your address, we locate. So they will display all your like organization name in the browser, address bar like true in like green color. And if they're more like larger enterprise or bank, so we know maximum the trust. That's the idea they can use. They would use the extended validation certificate. Okay, so these are some example about the digital certificate. And try to create one is called the self-created. Okay, so here will be the some guideline. If you have a server terminal, I recommend you can try to follow a step. So we can use the Open SSL. Okay, so this one is like common no matter on our Ubuntu server or if you're using Mac or terminal. So you can use Open SSL. First step, you need to like try to generate the key using the algorithm RSA to provide to generate output a private key. Okay. And second part, so we're using the RSA to create the public key based on our private key. Okay, so right now we have a pair of like private key, public private key pairs. Here will be our first step. And when we move on, so we need to try to use the private key to create a CSCI and contains your public key or other identifying information. So we can still using Open SSL request new, and then we will pass the key our private key. Okay, and then we try to create the CSR. Okay, the PM. Okay, so in this step, you provide giving some information. Okay, about your domain organization. Okay, so if you are watching and if you are interested, want to create your own certificate and see, please follow this step. Okay, and pretty straightforward. Just like put everything on your terminal command or your server, then you can able to do that. Okay, so once you submit to the CA, then it can take some time, a few days. Okay, for this part, you need to submit the CSR to the CA. But of course, like there's another alternative. I will show you like it's called using less encrypt. Okay, so that one is like pretty fast and straightforward. So this one you may depends on you which type, if you remember the domain or the organization or extensive. Okay, and after you obtain it, okay, so it will be like CRT, okay, or the PMM format. So you will have a certificate. So download it. So you can install the certificate. Okay, and try to install it. You are able to do it. And maybe on Apache or Nginx with a different way, but you can showing just like telling what's the SSL certificate file or then key file and then chain files right here. And of course you can configure it with the TLS SSL or this acting together to make your communication more secure. And we need to like verify a digital certificate. So we just need to like when they receive it, so they will check the validity first, the chain, and then there is the public key of the CA. So remember to verify first. Like we always try to verify, is this certificate digital signature, okay, of the CA? Make sure it's correct and it's still valid. That means they are not past the expiry date. Okay. not outside of that period. Okay, and then revocation check. So make sure that certificate they has been revoked by the CA. Okay, so this one can be done the CRL. So if they have a certificate revocation like this, or OCSP, online certificate state protocol. So either one, we can use them by this to check it. Okay, and then we can use for the TLS SSL to secure the communication. Then once you open it, then the server will send the CSL just like this. Okay, so you see this is the final result, and this is how we like try to verify. So when the browser open it, so it verify the certificate. So they will check the signature, expiry date, and then try to match the domain. Okay, so we can use it maybe use the public key to from the certificate to secure the exchange shared section. So maybe use this section to encrypt their communication, so they can use send the data, transmit it to server, or in reverse direction. So they will all encrypted with the session key. So they're all possible doing this way. And we also have some like common certificate managed tools. They just let you know we have the called the OpenSSL that we're using. So we can working with the certificates and key. So we can use to generate, converting, even verify the certificate. And for key tool, so this one is like provided by Java. So it can use for managing the certificates and key and support. Right now we are using support nowadays to create the Let's Encrypt. So it will automatically obtain and renew the TLS certificate from the Let's Encrypt. I will show you the page like how we use it for Let's Encrypt. And if like on the Nginx, like if you remember something on the server side, so after we generate the key pair, so after you create it, so we generate a key pair algorithm RSA is the same way on the server side and output it. Okay, so here would be same path. So it's we have a private key, so keep it on the server side and share the public key like part of certificate. And the next step we try to create the CSR, right? So if you remember, and then we have some information like maybe country name, state, or where like all this information, you just enter it, follow it. Okay. And after this, then you can like send it. Okay. So how can you send it? So using the support, if you're using Let's Encrypt, so it's a free and automated CA, then you can use the support to send it using the support Nginx for Nginx. This one is the domain name. If you want this your certificate serve for both like domain, because if you look at the record, sometimes we put a record like with the like www dot or without it, we can kind of two different path like the domain, and we can like want to the certificate serve both of them, then you can pass them together. But if you want to have a different certificate, then you need to do it separately, then don't pass it. Okay, so you can do it in this way. And actually it takes like pretty quick. So if anything, like if you own the domain and then you have configuration, then for this one, it will automatically generate a CSR. Okay, and they will try to verify using the HTTP1 or the DNS. One challenge depends on the setup. So later it will issue the SSL certificate. So this one will automatically save to etc and // encrypt under this directory with your domain name is a folder, so you can configure it. So everything goes well. Okay, so successful one, and then it can configure the Nginx using the HTTPS with the newly issued certificate. And because like right now for long time ago they will ask you need to edit, change the Nginx configuration by yourself. But nowadays, after you obtain the certificate, server help you to modify your Nginx server block. Okay, so you can like serve it as a HTTPS directly. And of course, you can install it if you are not using support or want to like install the SSL manually by yourself, or like using some commercial CA. Then when you receive the cert, okay, so you can create to have a private key you create earlier before. Then you can have a called the CS bundle. So this one may be the CSCA bundle.share intermediate share. So it will increase all the intermediate certificate. So use that for like establishing a chain of trust. So there, if you remember, like we have the chain of the trust in the last part, and then you can put it in any directory. This part will be just an example. You can put it under like etc, SSL, private, or any location. So just like put our private key certificate, okay, or the bundle cert under here. So they will go to all these, okay. And after we save it, just need to edit the Nginx configuration files, and once like using nano config the sites available, okay. You may be no idea about Nginx, okay. So but it just like letting you know, you can do it in this part and have some idea. And here's the Nginx server block. So when it listen to the port 80 and then have a server name, okay, let's say you have two domains, and this time we will just redirect it to from HTTP to HTTPS. So with the code like 301 is the redirection to the host. And finally, you see in the Nginx server port, we will listen to HTTPS. So the port is 443 with SSL. So if you see the TLS SSL will be right here. And the domain, so here will be the path or location where you will specify the location of your certificate and private key. So you can certificate, you can put the CRT and then certificate key. So you can put it right here. And of course, if you have a bundle, then you can add the SSL trust certificate. So you can add the bundle.crt. So this one, if you have it. And of course, we can add more like stronger SSL configuration. So adding the SSL protocol and the SSL cipher, okay, AES-128 like this, or SSL-256. So all these, okay, and adding the preferred server cipher on. And also there's an extra more. We can using BH power on this one. We can generate the key and adding it. Okay, so you can generate your own. Okay, and kind of last part will be the like the direct redirection. Okay, go to which folder to getting the index HTML or files. Okay, maybe some SS log. So for the rest of it, but mainly will be how can we configure it, and it's showing you how the website, okay, how it works. And there's a more like optional. So it's how can we generate the actual farm. So this one will be giving you a stronger security. So if you want to use it, okay, always recommend. Okay, so you can use the OpenSSL. So if you know like this one output, depends on how you say, you can like say as 1024 or 2048. So it depends on you change the it will take more longer time. Okay, maybe 1024, it may take maybe 5 minutes. Then if you're using 2048, so it takes maybe like 10 to 20 minutes. It depends on. So this one's optional, but it can help you to improve the security using SSL. Okay, so more encryption key, and then later just like test it using Nginx test. So everything goes well, then it's ready. Then you can restart the or reload the Nginx. So just like you need to once you like install everything, just like the server right here. So you can click on you see the certificate, the search, you can find all the content. Okay, so here will be like quickly showing you the next step. If you have a server, then you may follow all these steps, okay, to create a server. And I would like to show you one more is the right here. We're actually we're not giving all the some guideline and then some terms, but of course you can like Nginx install support, okay, DigitalOcean, and then when you search it. So nowadays it changed a little bit. In the long time ago, you need to like configure it on the server side. You need to install the Nginx, install the support, okay, and there's a Python 3 support for Nginx, and just like make sure your Nginx is always start. Okay, also like configure your firewall. Because later in the chapter, we will talk about firewall some like policy or this related to the network security. Okay, so right now, if you have no idea, for the firewall, we allow the port access. So we we'll be allowing the HTTP, that means port 18, or the HTTPS will be port 443. So if you see the configuration 443, that means we allow the firewall. Okay, so for the inbound, okay, and then just use the after the installation, just use the support and the configuration for Nginx and pass the domain. So it passes, it will put out the output. Okay, you can are you going to like no redirect? We always choose no redirect, and then if you successfully after you input your maybe if it is the first time using it, it will ask you, okay, input your email for contact updates, and then you want to contribute to it, like willing to share your information for support, like knowing you are using it. Okay, after if they verify, actually pretty quick. So within just 1 minute, so you will get the result. So if you configure something with error, then you of course you will get an error message, fail, you couldn't get it. But if you configure everything correctly, so we will get the output. It's a congratulations, and then you will get the certificate and chain. So under the etc let's encrypt live. So based on the first parameter, the domain, it will be the name. So if you put the www first, then the path will be changed to www.example.com like this. And it giving the full chain, the PM private key. So if you remember, and once you're able to check it, you can like using driver to test it. And the next part we as well as you need to change the configuration on the Nginx. We will this part under the etc. But because for the focus right here, I just want to let you know we can create our self use the digital signature, okay, our certificate. Okay, that's how we can create. So if you're interested, if you want to learn more, then I recommend you to try. Okay, install it. Okay, but sorry, because for the cybersecurity, we don't have to. If you are learning later, I know some students working on the web programming, okay, or like later have chance. Then for web programming, I told you like install the Nginx, configure the server side, okay, allow setting the Nginx, then you can try to integrate, okay, together and make it work, okay, together. And so far, quickly go through the lab. So this one would be like covering all the what we did and some extra, okay, information about the certificate. For the later will be mainly lecture, okay, our last part. So there are no labs, okay. So the coming like 3 classes we just like finish the last chapter related to this network security. Thank you.